Greetings to everyone watching. This is a video presentation for our capstone project. We start with a quick introduction of our team members, followed by the demonstration of the working of our project. My name is Tanish Tareja and I am from ENC7.
I'm Anurag Mishra of batch ENC7.
My name is Ishan Agarwal from batch ENC7.
Hello everyone, myself Jagat Chauhan from ENC6.
Hi, I am Kun Delvin from ENC7 and I am the team lead for capstone group number 16, and the project for our interim capstone report is obstacle detection and avoidance for an autonomous UAV.
The purpose of this project is to deploy a lightweight convolutional neural network, TensorFlow Lite, that runs in real time on a Raspberry Pi 4 to detect and avoid obstacles. With this project, we had three main goals. First, to be able to detect and classify objects with accuracy and reliability. Second, to make the UAV capable of performing avoidance maneuvers without any pilot input. And third, to use off-the-shelf components for easy reproduction of our techniques, so that anybody who needs to develop any kind of solution that involves an autonomous UAV can copy our methods and make an easy implementation into their project. So when moving along the path, if the UAV detects an obstacle, it will stop and try to get around the obstacle. After that, it will reorient itself towards the goal point and then continue on its journey till it reaches the final destination. Here we have TensorFlow Lite running on a Raspberry Pi 4. We are using MobileNet Single Shot Detector version 2 from 2018. This version has been pre-trained with 80 classes of objects, but we will be using only 20. These 20 classes are one of the most common objects that we hope that the UAV will encounter in its path. As you can see, the model is able to identify humans and label them into boxes. It can also identify small objects like smartphones. With COVID restrictions in place, the integration of a UAV was deemed out of scope for the project. So instead, we created a simulation on ROS Gazebo and tested our algorithm. As you can see, we are loading the ROS environment, Gazebo environment on our machine. Here we will load an SITL file to load a pre-prepared path for a UAV in the virtual environment. With the path loaded up, we can now load our algorithm and start with the simulation. Here we have loaded up the flight control. Now we will see a real-time simulation of our obstacle avoidance algorithm running in the virtual environment. Here you can see we have already loaded up the mission planner, and you can see the 3D model of a drone flying through the environment. You can see the drone's current position on the path on the bottom left corner, where it is going back to its home location. At the home location, we have placed a human 3D model which the drone will try to avoid crashing into. As you can see in the top left window, as soon as the camera detects the human presence, the forward bias goes to 0 and the drone is maneuvered to the left. After maneuvering and avoiding the obstacle, the drone is veered back onto its path. And now the drone is on its way. In this simulation, you can see the drone is trying to actively avoid a human that is walking into its own direction. See how the drone slides from right to left in order to avoid the human that is walking closer and closer to it. This has been all. Thank you for being a part of this presentation.